In this type of a galvanometer, a coil of thin copper wire is wound on a light rectangular frame. The frame is pivoted between two almost frictionless pivots and placed between cylindrical poles of a permanent magnet so that it can freely move in the region between the poles. The poles are suitably shaped and a small soft iron cylindrical core is placed at the axis of the coil. When the current is passed through the coil, a torque acts on it and is deflected. This deflection causes the restoring torque in the spiral springs attached at the two ends of the coil, and the coil indicates a steady deflection. The steady deflection of the coil is indicated by a pointer attached with it. Knowing the position of the pointer on a scale, current can be known. Principle and working. On passing the current, the coil will experience a torque, value of which according to the equation is tau is equal to NAIB into sine theta, where N is the number of turns in the coil, B is the magnetic field, A is equal to the area of the coil, and I is the current. Theta is the angle between vector A and vector B. The field being radial, theta is equal to pi by 2, and sine theta is therefore equal to 1. Therefore, tau is equal to N into A into I into B. This torque deflects the coil, and this deflection is opposed by the restoring torque tau dash due to the springs. Tau dash is proportional to the deflection phi of the coil. Therefore, tau dash is equal to K into phi, where K is the effective torsional constant of the springs. For the equilibrium position, tau is equal to tau dash. Therefore, NAIB is equal to K into phi. Therefore, I is equal to K upon NAB into phi. Therefore, I is proportional to the phi.